How big is the Milky Way? We'll answer this question in this episode of the C-Show Space series. How big is our home galaxy is just one galaxy among many. Yet despite its seemingly dominant presence in the night sky, we still don't know how big it is. For instance, we know that the Milky Way contains anywhere from 100 to 400 billion stars. NASA believes that there could be around 100 billion planetary systems like ours in the Milky Way. However, even if we include all of these stars and planets, that would only make up a fraction of our galaxy's total size. The Milky Way is comparable in size to the nearby Andromeda galaxy, which is about 2.5 million light-years away from us. You might think that Andromeda is bigger than the Milky Way because it appears larger in the night sky. This is an example of something called proximity bias. If you re-close to someone who is 2 meters tall and then you meet someone else who is 1.75 meters tall, but located 5 kilometers away, the 1.75 meter person will appear smaller to you. In reality, they're actually taller. This is what happens with Andromeda. It's not actually bigger than the Milky Way, just closer, and there are galaxies out there that are truly massive compared to the Milky Way. For example, IC 1101 is roughly 3.3 million light-years wide, almost 600 times the width of our own galaxy, and there are thought to be trillions of galaxies like this peppered throughout the observable universe. But the fact remains that the Milky Way is pretty darn huge. Let's take a look at some estimates for just how big it is. There are two main ways of measuring the size of the Milky Way. You can either measure it edge to edge or calculate its volume. The easiest way to measure the size of the galaxy edge to edge is to use light years. 1 light year is the distance light travels in 1 year, approximately 9.46 trillion kilometers. We can see that the Milky Way is roughly 100,000 to 200,000 light years across. That means that if you were to fire up your spaceship and travel at the speed of light, it would take you between 100,000 and 200,000 years to cross the galaxy from one side to the other. If you're wondering why it's such a broad range, it's because astronomers don't have a precise measurement for the size of the Milky Way. They've just got a best guess. If you want to measure the size of the Milky Way in diameter, that's a little bit more complicated. We can estimate the diameter by looking at the sun's apparent motion relative to the stars in the night sky. The sun orbits the center of the Milky Way at about 250 kilometers per second, and based on that orbital speed, we can estimate that the sun's distance from the galactic center, also known as the sun's galactocentric distance, is about 27,000 light-years. Multiplying that distance by 2 gives us a rough estimate for the diameter of the Milky Way. Again, it's an estimate. We're not like the tardigrades who can measure the length of a river by simply walking across it. We can't measure the length of the Milky Way by flying to its edge because we're inside it. So how do we get this information? Well, let's talk about some methods. One method for calculating the size of the Milky Way involves measuring the rotation of the galaxy. If we know the speed at which stars rotate around the center of the galaxy and we know how far away those stars are from the center, we can calculate the size of the Milky Way. This is basically the same way we figure out the mass of a star by observing its wobble. We can apply the same principle to galaxies, but it's not easy. Let's go through it together. Let's assume that we observe a star that's located far from the center of the galaxy. Since it's so far away, we can assume that its distance from the center of the galaxy does change very much over time. In other words, we can assume that the star is at a fixed distance from the center of the galaxy. Now, if we observe the star and find that it's moving faster than expected, we can conclude that there must be more mass near the center of the galaxy than we expect. This is because the extra mass would create a gravitational pull that causes the star to move faster. By measuring the star's speed, we can calculate the amount of extra mass that must be present. And once we know the amount of extra mass, we can calculate the size of the galaxy. It turns out that we have observed stars that are moving faster than expected. However, the problem is that we can't be sure whether the stars are actually orbiting the galaxy, or if they're just moving randomly. Stars move around due to gravitational interactions with other objects in space, and the random motion of stars makes it difficult to distinguish between stars that are orbiting the galaxy and those that are just moving randomly. There are other issues too. Stars that are close to the galactic center are likely affected by the gravitational pull of things like gas and dust. This makes it hard to tell if the star's motion is due to the gravitational pull of the center of the galaxy or due to the gravitational pull of nearby gas and dust. Another way to determine the size of the Milky Way is to look at the distribution of globular clusters. Globular clusters are groups of stars that are bound together by gravity. The Milky Way has around 150 globular clusters, and each cluster contains hundreds of thousands to millions of stars. Astronomers believe that globular clusters are among the oldest and most primitive objects in the universe. Because of their age, they provide an important window into the early history of galaxies like the Milky Way. And since they orbit the center of the galaxy, by studying them, we can learn more about the structure and evolution of the Milky Way as a whole. Globular clusters are especially useful for determining the size of the Milky Way because they are relatively easy to observe and they redistributed symmetrically around the center of the galaxy. In theory, by measuring the distances to a large number of globular clusters, we can map out the shape of the Milky Way and determine its size. However, this method also has its limitations. One major limitation is that we can only observe globular clusters that are within a certain distance of Earth. This is because globular clusters are so densely packed that they're difficult to resolve with current telescopes. As a result, we want to measure the distances to globular clusters that are farther than about 80,000 light-years away. Another limitation is that the distribution of globular clusters is not perfectly symmetrical around the center of the galaxy. As a result, using globular clusters to map the shape of the Milky Way and determine its size can produce inaccurate results. Despite these limitations, astronomers have used observations of globular clusters to estimate the size of the Milky Way, and their estimates are generally consistent with the estimates obtained from other methods. On average, astronomers estimate that the Milky Way is between 100,000 and 200,000 light-years across. So how big is the Milky Way? It's really freaking big. To put it another way, it would take you 100,000 to 200,000 years to travel across it at the speed of light. But even though the Milky Way is huge, it's just one galaxy among many, and the universe is so vast that even the largest galaxies are just a tiny fraction of the total. Here on Earth, we often feel like we're at the center of the universe. After all, our planet is the only one we know that supports life. But the truth is that we read just a small part of a small galaxy in a vast and ever-expanding universe. If you enjoyed this video, be sure to check out our other videos about the universe, such as what is dark energy or what is a black hole. And while you're at it, don't forget to subscribe so you never miss an upload.